Hi there, my name is Mitch Haralabidis, and in this video, which is part of a greater series of videos I have focused entirely on the AP Precalculus syllabus, we will continue our whole exploration on trying to connect the average rate of change of a function, which is a crucial topic for the AP Precalculus, with the function's concavity. Now, let me, without going in depth, I want us all from now on to remember these three things, because having questions on the average rate of change is something that we expect to meet in the exams at least 2 or 3 times. Remember that the average rate of change on an interval AB is given by this, f of b minus f of a over b minus a. Remember as well that we said in the exact previous video that when the average rate of change is positive, then function increases, and when the average rate of change is negative, function decreases. Now, if we remember this, that concavity splits in concave up and concave down, we should know from now on that the average rate of change is increasing if and only if the graph of the function itself is concave up. The average rate of change is decreasing if and only if the function itself is concave down. So this is the connection that we need to remember between average rate of change and concavity. The monotonicity of the average rate of change actually is connected with the concavity of the function. And now let's see a quick example. We have that graph. We have seen that graph again. Now, we need to find the intervals in which the average rate of change is increasing. Average, let me use average rate of change increasing means graph being concave up. Graph being concave up means curved upwards like a cup, or having a smiley mood. So it would be from here for sure. At some point somewhere here, it should stop. Why should it stop here? Because otherwise it would have continued expanding upwards like a cup, but we see that it doesn't. Also, from somewhere here, it should have stopped and then up to plus infinity. Now, the exercise wants from us to determine the endpoints. So what I'm going to do is I'm going to take this a little bit back. So I'm going to cut it at here at -1. And I will say that it is increasing. The average rate of change increases. So the graph is concave up from -3 included up to -1 included, union from 1 included up to plus infinity, because here we see an arrow. Similarly, the average rate of change decreasing, this means that the graph is concave down. And having a graph that is concave down means that we have a graph that is curved downwards like a frown. In this case, that would have been the interval. So we'll continue based on the points we used before, from -1 up to 1. And that would be all. Once again, I want to totally highlight the importance of understanding these concepts. Average rate of change, and monotonicity of a function average rate of change and concavity of a function. Regarding this video in where we tried to connect the concavity and the average rate of change, remember once again that the concavity of a function is highly connected with the monotonicity of the average rate of change. Average rate of change increases, the concavity is concave up. Average rate of change decreases, concavity is concave down. That would be all. If you found this video helpful enough, don't forget to like and subscribe, and we'll see ourselves in one of the following ones. As always, thank you for watching. Have a great day.